Hello and welcome to the Hub MT YouTube channel podcast brought to you by European Digital Innovation Hub and powered by MDIA, Malta Digital Innovation Authority. Our guest speaker today is an in-house speaker, and I'd like you to meet Mr. Trevor Sammut from the Malta Digital Innovation Authority, who has an extended experience in various fields of information technology, ranging from data centers, technical infrastructures, considerations, technical architectures, regulatory affairs, and innovative technology, societal impact and design. Basically, he was born, lived, and worked in technology.
I guess.
How are you, Trevor?
No, it's very fine. Thank you very much. It's nice to be here with you. Here we are.
Okay, so
Shoot
I
the
know
questions.
you
Yes.
at MDIA, but what was your journey? What was the journey that actually brought you to here?
The journey, I guess, you can say all journey starts since you are a little kid, I would say, right? And as a little kid, I was always a tinkerer of the electronics of the time, of course, which you could understand much more than you can today because they were designed in a more crude way. So there was like an initial very crude understanding from my end as well. And as a little kid, you know, we take toys apart, but maybe a bit differentiating from other kids, I used to build them back together and normally enhance them somehow. From then onwards, of course.
So toys played an important role
Yes,
in all
yes.
this.
Toys, tinkering with toys, and especially the mechanical ones. Sometimes some toys were not even, you know, kid-oriented toys, like maybe some tools that my dad had, or taking them apart and fixing them, or seeing how they work. I was always fascinated by this kind of stuff. It's almost like a kind of obsession almost, but understanding how things work, being curious, and hopefully that curiosity was not kicked out of me since then.
So you're still curious now?
Absolutely, all the time.
You're more curious, actually.
Absolutely, yes.
Today we're going to focus on HPC, which are high-performance computers.
Yes.
So my first question to you, when we say a high-performance computer, what are we talking about? What are we dealing with?
Yes, so high-performance computer, that's the word high, right? So it's all relative. I put a little disclaimer here. What is high performance? What is a supercomputer? What is a mainframe back in the 80s and 90s? It's all relative. So today, a lot of advancement have been made in the sector, but essentially an HPC would be a high-performance computer, which would mean more than 5 petaflop, for example, which is a very large computing power. Designed specifically to undertake specific tasks which are normally very computer-intensive. Meaning, just to give you practical examples, right? Because I don't want to be too technical, but also give practical examples. Let's say you have a process at home, you're doing a research and a study, and you realize that you're doing certain computations, iterations, what have you, on mathematics or on the physics side, or you do large data perhaps, or you're rendering something. And you realize, as video professionals often realize, that once they're rendering something, this might take them a week of rendering, 2 weeks of rendering, 6 months of rendering perhaps, or 6 months of computational power.
With its risks.
Yes, of risks. What if it's shut down after 3 months?
Exactly.
Or do I start from scratch? Does it continue? There's a lot of these questions. With high-performance computing, the idea is with such very specialized hardware, instead of taking 6 months, the idea might be that you'll take 6 hours. So there is this huge gap. That's what we're looking at. Of course, these values are hypothetical in nature because they will differ on a case-by-case basis. It depends whether code is optimized for a specific type of architecture of HPC. It depends on the task itself as well, what you're trying to do. It depends perhaps at times on the mathematics themselves as well, because the computer itself might not be optimized to work that particular mathematics in a fast way nonetheless. So, but in general, the high-performance computer would give you a huge advantage over waiting, or even experimenting. Let's say you're an experimenter. You're not going to experiment at every time. You're taking 1 month of processing power. You're going to experiment once, maybe twice, and then maybe give up, right? But if you realize instead of 1 month, you're taking 1 hour, you're going to do much more experimentation.
Or you're going to need more than one, because while one is being used for that time to render or to do something, you're going to need
That's
to work
another
on
issue, that once your computer is occupied with the processing, it's normally in a bit of a crippled state, right?
So you obviously need to fill your time
frozen,
somehow.
It's frozen, yes, out of use.
Let's look at HPC in different industries. So if I had to ask you, how are high-performance computers reshaping industries in healthcare and finance, for example, and maybe other industries?
We've seen a huge stride in the HPC industry itself. Before, a high-performance computer was required megawatts of power and gave you much less compute power in return. Today, especially in the past 2-3 years, as CPUs got improved, as GPUs vastly improved, the graphical processing units, we're seeing machines that output this type of computing power at much less electrical power needed and much less thermal compensation, meaning much less need for excessive investment in cooling. So everything ties together, everything must, at the end of the day, obey the rules of physics. So thermals will be there, consumption will be there. So we've seen a huge stride there, and the effect that they had on the medical field, for example, or molecular biology. Just to give you a practical example, once again, I like to associate things together for practical purposes. COVID, for example, one of the discoveries of the protein spike itself and the compatibility the vaccine had with the protein spike of COVID itself was thanks to high performance computing and artificial intelligence to determine the connection there. And both areas of field of science require excessive computing power.
So yes, in that area we can see.
Without such HPCs, these discoveries very likely would not be possible.
What recent advancement would you say that an HPC holds the potential to influence specific research and innovation?
Yeah, absolutely. Space sciences comes to mind at this very moment during this interview, because this is one of the scientists that generates huge amount of data. And sometimes, although the computations might be simple, you might have a bottleneck because the data is so huge. So when the data is so huge, you need the machines, once again, you need the storage, and you need the machines to process them one after another. And maybe you're running AI on it, and then you need to categorize galaxies. You need to categorize and discover our space, our role and our existence, because this is a study really and truly about the universe and therefore our existence, right, in it. That's one field. You have the medical field, which we mentioned. Finance could be another field, and essentially what the common thing here is data. Huge amounts of data that need to be processed, or algorithms that will, as an output, generate huge amount of data, and then on that data you need to do further computations. And this is like the bottleneck of the research itself at many times, as many science students can tell you, and even people in the industry can tell you this, where they have a lot of data sitting there, and how can we work with this? What do we need? We need this compute power. Oh wow, I can't afford to do this huge amount of compute power invest to see what happens with this data, because remember, there's a huge element of experimentation.
Yes.
So you might run a lot of these computations, and the result in, if you have a result, now what?
And high costs. High cost besides obviously
Yes.
time consuming as well.
Yes, you have the high cost of the hardware itself as well, but sometimes you have a cost of just sitting on the data. So if I invested so much in other systems and I have this intelligence data, how can I extract intelligence out of just the data? It's still being expensive of you just leaving it there in terms especially of a business.
It's still a waste.
It's still a waste, and it's a costly waste.
It's a costly waste. If you had to, for example, tell us how do cluster of high-performance computing systems contribute to addressing complex global changes, such as, for example, the climate modeling or molecular modeling, and similar maybe R&D activities?
Climate analysis, climate forecasting, climate study, for example, is another field of environmental science and earth sciences, where the use of such HPCs is a must, right? Now, since you scaled up a bit for me, because you mentioned the word clusters here, right? So we're just not talking just one simple HPC machine, but a cluster of them, right? Consider it like a farm. In
Like
fact,
a
in
lab.
rendering, the word that is used is called render farm. Because it's like a farm, right?
Okay.
And so yes, you can have a GPU cluster, multiple GPU clusters working together. One of the grandest goals and objectives of the European Union through the Euro HPC joint undertaking is actually to make available for researchers the huge high-performance computers existing in Europe, having different architectures available for use for scientific community. And again, these are normally huge clusters, a very large scale. Some nations have more advantage over others because sometimes of the climate itself, because cooling then really becomes an issue. So if you're living up in the mountains in the snow, you can open a vent and breathe in.
You're done.
See, but
it's cool.
You know, so
Here
there are also
it is.
Geographical challenges, electrical connectivity challenges. Yes.
Especially, I think, when a render farm would be experimenting with such.
A render farm, which is another type of HPC, focusing normally on video modeling, rendering, and once again, yes, I think one of the practical applications, or practical, it was in entertainment, right? It was like a bit of, wow, look at this film, it's so different from the other. It was actually a Pixar movie, or Pixar movies from the beginning, like Toy Story, for example. Those were rendered on render farms of this kind, and still they took many months of rendering
To be able to come up
to
with the final
produce
product.
the final product.
If we had to go into the mechanics and the technical terms of it, what differentiates a traditional personal computer from an HPC in terms of hardware and also capabilities? So that even someone watching us and watching this podcast would say, but what's so special about this besides the high power, because it's within the name, and we're now understanding what it is used for. You're not using this computer to send an email.
I'll give some tips out as well, so it could be helpful. Essentially, the brief answer is architecture, right? Architectures differ from each other. So you have x86 processors like Intel and AMD, the consumer grade ones. And here we might be talking about a GPU cluster. So CUDA compliant clusters, or you have, you know, NVIDIA, for example, is essentially one of the most commonly known hardware manufacturers who do these types of machines as well. And it used to differ a lot in the past, but if we're talking, for example, about CUDA compliant systems, at home, if you have an RTX based card, right, for the people out there would know what I'm referring to, you can install the software development kit on your RTX, and you will have the CUDA SDK kit, and whatever will run on your system there at home will run on GPU-based systems which are CUDA compliant. So now we're seeing a bridge. We're seeing a bridge where before traditional high-performance computers were so architecturally different from what you can have at home that you had to learn how to code for them. You had to learn how to interact with them because they use totally different, very weird libraries, or different languages.
So
to
they weren't
actually
very
optimize for them.
user-friendly, I would say.
You had to be a scientist where you had to read a lot of documentation based on a particular architecture. And then, but today we're seeing this bridge. And the idea is also at MDIA is to have this as facilitated as possible. And support is always required for the scientific community, and not just whoever is going to use the HPC, to optimize their code accordingly to make the best use out of this wonderful machine.
In fact, I was going to ask you, you being in this industry, what changes have you seen also in this area throughout the years?
Huge changes where the cost per petaflop just dropped down drastically. 1000% is an easy guess since the last 20 years or so. And this makes these devices extremely accessible. Now, by saying extremely accessible, it is still not a trivial undertaking. And this is why authorities such as us, delve into these projects to facilitate the local market, businesses, researchers, etc. But this has been a huge change, because before, something like this would have been out of reach even for us.
In fact, I was going to ask you to give us some details of how initiatives like DHubMT can actually help in this sector, not only when it comes to the computer per se, the HPC in itself, but even also for maybe in usage, maybe in discovering options.
Yes, DHubMT, not because I'm part of the team, but you'll forgive a bit my
We're factoring that in, yes.
It's a very exciting project. And the idea is to have available here at MDIA, the DHubMT, facilities which can be out of reach, especially for startups, can be out of reach, especially for students doing intensive research. And remember, research, the path to innovation is almost always based on some kind of research and a trial period. So in the research period, if you're trying 10 things and one sticks, and the 9 others are nothing, you've been very successful. That is good. You have to give a chance for this to develop, because that one thing that really stuck could be something so novel, it could be what we call one of these unicorns in the long term, right? But you need these tools to work with. You need 3D printing, for example. You need these labs based on IoTs. You need electronics engineering lab. You need an ESD safe area where to work on electronics and experiment on perhaps robotics or something along those lines, right? You need the availability of an HPC. That would be that would be a that's a catalyst which did not exist before, and that would be available then. So surely that's going to have a mark on the whole ecosystem of the island. So that's the idea, to have these available at DHubMT. You can get an office, stay at the office and focus with your team as a startup, and delve into see what the tools are available and what you'd like to use, and you take it from there. There's a healthy and a heavy element of experimentation, which we will allow and also actually encourage.
I'm sure that initiatives like this and the availability of the HPC would actually meet the increasing demands of data processing and analysis in the fields of AI,
That's what we're saying,
machine learning and research. I think
Yes.
all this, making this doable for anyone out there.
In terms of AI and machine learning, especially those two fields, given that we're looking at tensor core-based processors, right? So there's an extra added advantage, because the processors themselves are going to be optimized for that kind of load and work. Not just, but there's some optimization on the hardware side on that. Yes, we do mention machine learning. We've been mentioning AI for quite a number of years, of course. Malta has been one of the forefronts at teaching artificial intelligence at university, for example. But the questions always lingered. AI, but with what I'm going to work? I have this 1 gig of data, which is really small, really, on my laptop. And we've seen tries, and we've seen even both the local scientific community and companies trying to buy these small machines, because that's what they could afford.
It's true.
Small machines, I'm talking about a computer that costs, say, 4,000, 5,000 euro. That's still considered small on the HPC scale, right? But with this, they still get somewhere. And that shows us, through even our research we did on the topic, that there's the demand, there's the want, there's the need.
There's the capability, and the capability is there.
Yes, the capability is
And
there,
that's
and there's the want
phenomenal.
for it, yes.
So I think
That gives us courage,
yes.
especially the feedback we're getting on the topic as well.
It's useless having the capability, and then it's a pity not to have the machinery to work on, or the other way around. You would have the machine
But
available.
that's often
and
the
not
case with
capability.
startups, right? For example, they might have this fantastic dream, but they have these necessary tools not within their grasp. Or perhaps sometimes the best tool can be simply expertise. Let's not just think on the hardware side. Okay, it's nice to have a vector network analyzer. You're going to have, say, proper soldering stations, and maybe experiment with RF, right? And oscilloscopes, what have you. It's nice. But sometimes what you know is the guide. What you need is really the guidance, the expertise. And the DHubMT will also be offering
mentorship.
Mentorship, yes, key mentorship. And then there's, of course, the non-technical side, which is technical in itself nonetheless, of setting your startup up. We have specialized experts on that area alone.
So talking about dreams, Trevor, what would be and what are your dreams in this sector? What do you wish or imagine or think or predict that's going to happen?
Prediction in technology is always a bit of a fool's errand, right? But of course, what I can predict safely is that technology will continue to grow, continue to be ubiquitous everywhere, and necessary part of society, and especially in business use, even domestic use, everywhere. It's just about everywhere. So that's a given, right? A dream, and the dream I have is we see DHubMT grow. And grow exponentially. Of course, we're doing huge strides in this area. This has been a dream, a 3.5 baking dream. Now that you're seeing some parts of it starting to come out, so it's always a lot of work in progress, and we're envisaging the future as we're trying to anticipate it, even on these machines, even on when artificial intelligence, even before there were any grasp of AI and AI regulations. MDIA was at the forefront, and we were thinking about AI way before there was any mention of this type of popularity we have today on artificial intelligence, machine learning, algorithms, data, statistics, and what have you. So yes, the dream is there. It will always be there, and it's very hard. It's a very hard dream to extinguish, because being in the industry, we know what's needed out there, and we know what the frustrations are, and the idea is to make things as easy and smooth as possible, and learn together. I think that's stay curious, and this applies for everyone.
Ladies and gentlemen, that was Mr. Trevor Sammut, one of us here at MDIA, Malta Digital Innovation Authority. Thank you for watching.